Again, welcome to Calculus Mathematics 200. In these lectures, we're going to cover the derivative rules. So our main objective is to find the derivative of a function using the constant rule, also using the power rule, and using the constant multiply rule. So we start with the constant rule. Here we say that the derivative of a constant function is always 0. So derivative of any function that have only a constant value is 0. So let's see an example. The function y equal to 7. Again, 7 is a constant value. So the derivative of y, which is dy dx, is 0. Now the function f at x equal to 0. The derivative of f at x also is 0. Now, s at t equal to -3. -3 is a constant value. So the derivative of s at t is 0. Next, we have y equal to k power square. Here we assume k is a constant value. It's not a variable. K is a constant value. And we know power is 3.142. So that means derivative of y we give us 0 because k is a constant value and power also is a constant value. So again, the derivative of any function that has only constant value is 0. Next is the power rule. Now the derivative of f at s equal to s to the power n. Since s raised to the power n, we will use the power rule, which will give us n. So the power n become a coefficient. So it will be nx. Then we reduce the exponent by 1. So the derivative of x to the power n is n times x to the power n minus 1. Now, for a function to be differentiable at x equal to 0, we say n must be a number such that x to the power n minus 1 is defined on an interval containing 0. So when using again the power rule, we say the case for which n equal to 1 is best thought of as a separate differentiation rule, which is derivative of x, the answer will give us 1. And the power rule when n equal to 1. So let's see an example. Here we have a function f at s equal to s cubed. Again, 3 is a power. So we have to use the power rule. So derivative of f at s will give us 3x squared because we get 3x to the power 3 minus 1. So the answer will be 3x squared. Next, we have the g at x equal to cube root of x. We know cube root is an exponent of 1/3. So this means derivative of g at x will give us d dx s to the power 1/3, which is cube root. So we have 1/3 as a coefficient. Then 1/3 minus 1 will give us -2/3. So our answer will be 1/3 x to the power -2/3. The reason why we have -2/3 because again the power rule is the exponent minus 1. So 1/3 minus 1 will give us -2/3. And we can rewrite it as 1 over x to the power 2/3 times 3. Because we find the reciprocal, change the negative exponent to positive. We bring s -2/3 down. Now let's see a third example. Y equal to 1 over x squared. Here again, we have to use the power rule because s raised to the power 2. So we can rewrite 1 over x squared as x to the power -2. And that's what we have here. So to find the derivative, which is d dx s to the power -2, -2 will be a coefficient. Then we have to subtract 1 from -2, which will give us -3. So our answer will be -2 x to the power negative 3, we change it to positive, so we bring it as a denominator, s to the power 3. So the answer will be negative 2 divided by x to the power 3. Or we can write the answer as negative 2 x to the power negative 3. So in example 2c, as we saw, we should know that before differentiating, 1 over s squared was rewriting as s to the power negative 2. And we can rewrite it. It's the same first step in many differentiation problems. So for example, y equal to 1 over s squared, the best is to convert it so that s squared will be numerator. Then it's easy to use the power rule. So you get s to the power negative 2. Then we differentiate it. We have negative 2 as the coefficient of x. Then negative 2 minus 1, which gives us negative 3. Then we can rewrite it to remove the negative exponent to positive. Next is the constant multiply rule. So a constant multiply rule means we have a function with a constant value and a variable. So for example, here we say CF. So which means the derivative of CF at x, we don't touch the constant. Now, this is a little bit difference. There's a big difference actually between constant multiply rule and constant rule. A constant rule means the function have only constant value, so it's 0. But constant multiply means the function have a constant value with a variable. So we are going to leave the constant value alone and we find the derivative of the function. So let's see an example. We have y equal to 5s cubed. Now, if we have y equal to 5, then we use the constant rule. Y equal to 5, the answer, derivative of y will be 0. But here we have y equal to 5s cubed. So we are going to leave the 5, then we find the derivative of s cubed. So here you can see how we rewrite it, 5, then derivative of s cubed. Now, derivative of s cubed will give us 3s squared because the power will become the coefficient, 3. Then we reduce the exponent by 1, so 3s squared. So the derivative of s cubed is 3s squared. We multiply it with a constant value, which is 5. So our final answer will be 15x squared. Next, we have y equal to 2 divided by x. We need to rewrite this function. Why? Because the variable is a denominator. So we can have 2x to the power negative 1. We leave the 2 alone, then we find the derivative of x to the power negative 1, which will give us, again, negative 1, then negative 1 minus 1. Always we have to reduce the exponent by 1. So negative 1 minus 1 will give us negative 2. And we have our negative 1 times 2, which will give us negative 2 also. Now we want to change the negative 2 exponent to positive. So we bring the x to the power 2 as a denominator. So our answer will be negative 2 divided by x squared. Let's see the next example. F at t equal to 4t squared over 5. So here we can see our constant value is 4 by 5, or 4 divided by 5. So we need to find the derivative of t squared, which will give us 2t, because the 2 will be a coefficient, and we have to reduce the 2 by 1. So we rewrite 4 over 5 t squared. We remove the 4 over 5 constant value, then we find the derivative of t squared, which gives us 2t. Then 2 times 4 will be 8, divided by 5 and t. Next example, we have 2 times square root of x. As we all know, square root of x, the power will be half. So we rewrite as s to the power half. 2 will be removed out. Then we find the derivative of s to the power half, which will give us half s to the power negative half. Why negative half? because it will be half minus 1. Half minus 1 will give us negative half. So the 2 can cancel the half, and our final answer will be x to the power negative half. We can rewrite it as 1 over square root of x because we change the negative half to positive. Next, we have y equal to 1 over 2 cube root of x squared. Again, here our constant value will be 1 over 2. So we have 1 over 2 out. Then we find the derivative of x to the power negative 2/3. Why negative 2/3? Because x squared with the cube root, they are all denominator. So we have to now cube root, as we said, is the power half. So 2 times half will give us 2/3. And because it's negative, because it's positive and at the denominator, if we bring it as a numerator, we will change the positive sign to negative. So that's why we have s equal to negative 2/3. So now we find the derivative of s to the power negative 2/3. It will give us 2/3, negative 2/3 x to the power negative 2/3 minus 1. Now, negative 2/3 minus 1 will give us negative 5/3. So our final answer will be half times negative 2/3 x to the power negative 5/3. And the 2 will cancel each other. So we get negative 1/3. And s to the power 5/3, we change it to positive exponent. So we bring x to the power negative 5/3 down, and it will be s positive exponent 5/3. And one more example, we have y equal to negative 3s/2. So we take negative 3/2 as a constant value. So we find the derivative of x. Now we know the derivative of x will be 1 because 1 will be in the front and 1 minus 1 is 0 as the exponent. So s raised to the power 0 is 1. So the derivative of x is 1. So our answer will be negative 3/2 times the 1, which will give us negative 3/2. Again, derivative of x is 1, whether we use the power rule, because x means s to the power 1. So the 1 will be a coefficient. We get 1x, and the exponent will be 1 minus 1, which is 0. So 1s to the power 0, anything raised to the power 0 is also 1. So that's why we have 1. So here we should know that the constant multiplier rule and also the power rule can be combined into one rule. And the combination is as follows. So we have a derivative of c s to the power n. It will be c times n x raised to the power n minus 1. And this is what we use like 2 different occasions. Always leave the constant value alone. If you have s to the power n, then find the derivative of s to the power n and multiply by c. So that's what we have here, cn s to the power n minus 1. So that will be the conclusion of this lecture. So in these lectures, we learn how to use the derivative formula for constant rule, and also for power rule, and also constant multiply rule. So again, see you in the next lectures, which we are going to cover the sum difference rules.